the first time we do a live stream, actually. So it should be interesting. Okay, thanks everyone. So I believe we're live. So I want to thank everybody who's watching us, and the attendance who's here, but also the people who are live. Actually, we were very excited to see how many people were interested in what we have to say today. We had lots of interest on social media and the like. So to introduce myself, I'm Karim Beguir. I'm the co-founder and CEO of InstaDeep. InstaDeep is an AI startup which is focused on really delivering innovative products and sort of like pushing the envelopes of what can be done. And so, as you know, today we have a surprise. We didn't want to reveal, what it was about. So without waiting further, I'm very happy to introduce you to our new product, which is this one. So for the first time, we're happy. Thank you. Presentation. So we're very excited to tell you more about DeepPCB. So basically, this is an electronic design automation product, and we're very excited about it. Actually, we believe it is the first. We've checked the first like PCB router which actually looks at solving this problem using pure AI. So this is end-to-end AI, no man in the loop, purely cloud-based. And I want to thank all the team who's worked very, very hard to make this a reality. And together with Nabil, our lead hardware engineer, we're going to tell you more about what's going on there. So let's look into what we have. So first, I want to explain why we decided to focus on this specific problem. There are many uses of AI, but why we thought this problem was really compelling? I mean, it really comes in the end from, what is happening and what are the needs of users. So let me take an example. On this ATM board, so this is what we call a printed circuit board. So it is a component of electronics that you find in pretty much all products, and which is key here. In this particular case, this ATM board is used for energy consumption and detection. And so the problem that we are looking at is essentially how do we connect the different pins and components on the chip. So you can see here the different lines that are connecting those pins. Like, how do you connect those? And this is an interesting one. And typically on printed circuit boards, you have multiple layers. So this is one layer here, and this is the second layer. So typically you have at least 2 layers for simple printed circuit boards, but it can be many more. And the interesting point here is, how do I connect those? And it's actually not such an easy problem. And if you look at what the users are saying, this was a bit earlier this year. This was in March of this year. These were the kind of comments we could see online. So basically people saying, the current autorouters are not spectacular. I usually manually route my PCBs. Manually, this is really interesting. In 2019, with all the progress of technology and AI, we are still making those connections manually. And it takes a ton of time. This is actually one of the comments we picked up from KiCad Forum, which is a very active forum for PCB hobbyists. Another one In comparison to chess algorithms, routing algorithms seem to be less developed. That's interesting because there's been a lot of progress in chess and the game of Go, as you know if you've been following AI news. Same thing is, most of the time I do the joke. When the design is finished 100%, and when we say design finish, it usually has a manual component into this, I start the autorouter. There is rarely over 80% when autorouter ends. Like basically autorouter does not complete all the connections. It usually completes something like 80% of those connections. And we've seen many of those commands. And at InstaDeep, we have we are lucky to have both domain expertise in electronic design, but also advanced knowledge of what AI can do, and in particular, what AI can do that has not been done. And we found this problem extraordinarily interesting, and we decided a year and a half ago to commit significant resources into looking into it and possibly finding solutions that users want. So if I am to summarize what's going on here, we are saying that PCB routing today is very time consuming because it's done manually, and this is particularly the case when you have like complex boards. It can take weeks, if not months in specific cases, using like specialized hardware, basically engineers. And it relies on human knowledge. Like this is really like a case where the expert sort of has had a lot of, many years spent on the problem and sort of starting to understand the intricacies of it. So in a sense, it's like chess champions. They have spent years training and sort of they have this magic intuition, which makes the difference, right? And that's what's happening in PCB routing today. And importantly, as we said, autorouters are very limited. Most of them actually use heuristics, which are sort of like rules about how to do things, the same way that, in previous chess programs, and this is before 2017, best chess programs such as Stockfish were a mix of computer scientists, like experts in programming, but also like chess champion that would say, hey, you should do that, and you sort of program those complex rules that can be sometimes in the hundreds into a software which is efficient. So our approach with DeepPCB is to basically completely, disrupt and innovate when we compare with what is happening here. So first, rather than waiting weeks or months, our goal is to solve printed circuit boards routing in less than 24 hours or 24 hours at max. This, if we manage to do this, this would have a huge impact for users because it would mean that they can effectively, advance into their development cycle. And there are lots of people working on different products, whether it's, like Bluetooth speakers or any other IoT components. All of those use printed circuit boards. If you could save weeks or months into your development, that is actually something massive. Importantly, we're also trying to avoid using heuristics. This notion that, hey, the human expert knows better has been true until now, but there should be ways using data-driven advanced artificial intelligence methods to go beyond those heuristics and sorts of rules that actually come from the experience of people who've been working on this subject, but which are necessarily limited by the amount of experience and true time they spent on it. And finally, we want something which is robust. We want something which adapts quickly, and ideally, like, you do not have to tweak anything. Everything is automated end to end. You just basically provide your board to DeepPCB and it does its magic. And this is basically the work we've been working on. So I'm very excited actually to showcase for the first time DeepPCB. So this was a dream a year ago, and I'm very excited that we have reached the moment where we're doing the beta release. So without waiting further, I'm going to introduce basically Nabil Chouba, who's our lead hardware engineer. Nabil has very significant expertise into this problem, has worked for more than 15 years into like elite electronics design companies, some of them who've been purchased by Apple. So Nabil, over to you.
Hello. So I'm going to talk more about the technical side of the project. So I choose the same board that as Karim showed in the beginning of the project. It's the ATM board. It's an energy meter board. So what it do, it measures the voltage and the current, and by multiplying the two, you get your consumption. So basically, the main chip is here. It's ATM chip. It has a bunch of ADCs and do the sampling. And what it do too also, so it step down the voltage using other circuits that are here basically. So the voltage from 12 degree go to 9 degree, 9 voltage. Okay, so it has also two interface. You have a SPI interface and you have a E2C interface. And so a board is a bunch of components spread everywhere. And for every pin, so a component has pin like this, and for every pin, you have a connection. So this pin should be connected to this one, should be connected to this one. So you see the complexity is really enormous. So as you see this place, there is a big congestion there. And the job of the guy who is going to do the routing, first he's going to place the component, and next he's going to do the routing. By doing the route, he's going to connect those points using wires. And there is rules. So the electronic engineer, they call those rules design rules, and they have a checker, automatic checker, it's DRC. But when I joined InstaDeep, so all the guys was ML researchers, so for them it's a game. So they used to play Go game and Atari games, so that's why I put rule of the game to talk with ML guys and DRC to talk with the electrical guys. So basically, when you have wires like this, so the two wires, they need to be separate by a fixed space, which is a minimum space. We call this the clearance. The other rule is that a wire has a width. So you have always to use that width. You can use bigger, but you cannot use smaller, because if you use smaller, the current will not pass. And for the clearance, why we have that clearance? It's because you will have some defect in the manufacturing, so you need to separe them a little bit, else they can touch, so to improve the manufacturing yield. And the other rules is, as you see here, you cannot do 90 degree. You have always to do 45 degree. So you can only move by doing 45 degree. So here, for example, he do 45 degree, and now what he's doing, he put a via. He go from one layer to another layer. So he put a via, and a via also it has a clearance space. On that clearance space, you need to be sure that there is nothing on that area. It's like private space for people. Once you are sure that everything is clean, you put a via and you go down and you continue down. So this is on the top and this is on the back, if you can see. Okay, so let's move on. Okay, usually when we start doing design, the first thing that you do is you search on the internet on all the components. Like you are going to do a Bluetooth board for IoT. You search all the Bluetooth chips, and you select the one that has the resources that you need. For example, one ADC, 12-bit, plus a Cortex M0. So once you made all your research, so you put your chip, and you put other component that will provide the supply, that will provide the clock too. It's like this one, provide the clock, and you do the connection. Your connection. Those are debugging jumpers. Once you have done this, the second step is placement. So you place your component on the board, and the tool automatically know that this pin is going to be connected to this one from the schematics. And in our case, what you need to do is that you need to save this file after placement. You give us the files, and we do the auto routing for you. Okay, so this is the same board as Karim presented at the beginning. It's the ATM board. So this is a solution which fully connects the board. So this board has 160 pin, and it has. A
point I want to make here is actually this is the real professional board that we've seen in the beginning. So what you see here is not sort of a simulation or like an ideal case. This is actually reality. So it means like the design that this DeepPCB has delivered actually can be used by like electronics engineers to build products. So this is basically the real world, and Nabil has been working immensely with his team to make sure we comply with all rules. So this is actually a real production design.
Yeah. Yes, it's a real board. And the complexity is that we need to connect 116 pairs. And the routing that you see here is designed by our autorouters. So if you can see our autorouter, he supports multi-net, so a net which is connected to multi-pins. Usually it's the ground or the supply that is connected to multi-pins. And also the yellow thing is the clearance. So the top layer is on red, the back layer is on blue, and whenever you go down, you put a VR and you check the clearance is okay. The other thing that we see in green here, it's keep out. So those places you should not go. Usually it's just a hole for the package. Okay, so for this board, we are able to fully connect all the wires, and we choose this board because it's a really complex board. So we compare our solution with the available free router, and this is the solution of the available free router. And as you can see, he cannot connect this one, and he cannot connect this one. But in our case, we connect them all. So we can say our solution is better in this case than the free router that leaves two wires unconnected. And you see the solution is completely different. So, and you can see from here that the space of search is really big. So you can do a lot of permutation and things like that, and you push wires, and everything is going to be different.
Also want to mention, this is a significant milestone for us, because one of the goals when we started the project, there was a big question, like, could we get to a level of performance which is equivalent or better than available free routers, right? We know that free routers and auto routers that are in the market today are not enough, but that's a first important benchmark. And so we're very excited about this result. The fact that DeepPCB can, on its own, without any pre-canned rule, I mean, I want to emphasize here, the free routing engine that you see on the left has sort of like rules that it follows, and it basically copies them blindly and always does the same thing. In this particular case, DeepPCB is an AI-powered system that's going to learn to solve the board. So it's going to explore potential solutions and refine from there. So we were not sure when we started this project that this would be possible. And actually, we're very excited. And this is also one of the reasons why we decided to release the beta version, is like we reached that stage where the AI system on its own, without any sort of like initial heuristics, we don't tell the system how to solve the problem. We just tell the system what is a good solution or not once he has come up with a proposal. And just by doing that, getting this kind of results feels like, you know, we're very optimistic about the future. Like what those systems can deliver for users could be fantastic. And again, this doesn't need manual tinkering by engineers. The system runs end to end. So for us, this is a significant milestone.
Yeah, and the beauty is that it's based on RL. So if you go and test this board again on the web, you will find a different solution because our RL solution keeps improving over time. And also it's a better version, so we are improving some wiring. Okay, so let me do a live demo for you. You know, live demo is always tough, so let's see if it's going to work this time or not.
We hope it's not the Cybertruck moment.
Okay, so let me try, okay. So what I will do, I will start with KiCad. Okay, let me remove all the infill all. Edit. So I'm going to start from scratch. So the board is unrouted. So this is the board. Just let me zoom out. Just a minute. Okay. So this is the board. So usually what people do is you need to export the placement. So you do export. You go to generate a DSM file. You save your file. Replace. Okay. Once you've done this, you go to our internet site and you do new project. It's easy. Huh? You just upload the file. You go to your DSM file that I have already saved. You select the file, choose. you call your project something. Let's call it this. Submit. So once it's submitted, what our platform will do, it will generate a picture of your board and put it on the system that you see that it's submitted, and it will keep updating you with the progress. So it will send you a file. Okay, so let's check again. So this is the board that we have submitted. Okay, so he needs some hours to find the completely wired, completely connected solution. Also, what he tried to do is he optimized the number of vias, and also he tried to optimize the length. So he reduced the length. Okay, so let me check another board for you, because we cannot wait for 1 hour. Okay, so usually when you send your board, you will get a picture like this. So this board is finished. As you can see, the routing is already done. Okay, and you can have also 3D picture. Okay. You can turn it and you can see the wiring on 3D. Thanks, guys. Okay, and it tells you how many connected wires you have. So it's fully connected board. All of the wires are connected. It provides you with the SES file. It's the file session spectra file. You load this file, and what you do is you go back to your KiCad tool. Back to KiCad. And you import the SES file that we generate for you. Import spectra SES file. This one, okay. Okay, and you have your routing already. The other step that you have to do is also you need to fill the plane. So we support plane, and that's it. So this is a full demonstration of KiCad. We are also working on integrating a plugin in KiCad, so that you don't always connect to our site and come back and go to the site, save the file and everything. So we have here a plugin that you can see here. It's implemented. Yep, it's this one. Let me make it smaller. So yeah, it's this one. So those are the two plugins that we have. So you can send the file, and once the file is ready, it gets uploaded and it shows you the solution, and also do animation for you. We are going to release this plugin in the future, but currently we are releasing the platform. So.
Yep. So importantly, so all of this is available today. So if you connect to deeppcb.ai, you will find the website where you can upload your boards. Just create a login and you can upload your boards. Maybe we can show the website just very briefly.
Yes.
Yeah. Just to give you a sense. So it's really as simple as it should be. You have your file. In this case, we use DSN format, which is ready. Just upload your board. Wait for 24 hours, and again, you're saving significant amount of time compared to weeks, if not months in certain cases, and then you just download the solution. And it still works with the tools you're used to, which is KiCad and open source tools. So that means that, you don't have to change your working habits. We've worked a lot on creating those plugins such that immediately, like, the solution you get is compatible with existing open infrastructure. So we believe that the solution going forward in PCB routing and electronic design is a mix of advanced tools such as DeepPCB, but also like open source tools, and making sure they work well together so that you can get maximum results effectively. Yeah. And maybe we can show the front of the website, like deeppcb.ai, just to give you a sense of what we have. Yeah. So this is to show you. So the website is available now. You can actually go check it out. We've worked with our partners. I'll mention that. But really, it's as simple as upload. Wait for 24 hours and download, and you have all the specs here, and you can register there. So we're just opening it now as we speak to basically the electronics design community and PCB hobbyists, engineers, and we'd be very interested in their feedback. The goal of this exercise is also to communicate, to explain what's the, the potential with artificial intelligence, but also to get back feedback, because we believe we are at the beginning of the journey, and there's a lot of lots of exciting things coming next. So maybe we can say a few words about the technology behind all this. So yeah, maybe Nabil, you want to say about future releases? Yeah.
Yeah, as I said, this release is a beta version, so it keeps improving over time. On the next release, we are trying to support more complex board. Currently, we support only board that has 200 pin and 150 weighted nests. So on the future, we are going to improve that time. We are going to support bigger board. We only support 2 layers for now. And we are working on supporting differential pairs and matched impedance wires. What it means that sometimes you have to connect two wires, and the length of the two, they should be the same. So this is currently is not supported. We want to work and improve our plane support. And the other thing is we are working on making the wait time when you send your board. Currently the wait time is like 2 hours, 3 hours, until 24 hours, but we are working on it to reduce by 10 times. So,
thanks a lot, Nabil. Yeah. Well done. Yeah. Okay, so we survived the live demo, so I'm glad. So let's maybe speak a little bit about what's the tech behind all this, because we believe it's a very exciting time in AI, and particularly like in advanced applications of AI. So really, I believe what's the deciding factor technologically here is reinforcement learning and deep reinforcement learning using basically neural networks. So we've seen incredible progress in this space. It started, of course, with the original DeepMind result about Atari games with a breakout displayed here on the bottom right that you see, and then progressively getting better and better results. Today, OpenAI has reached significant results about hand manipulation using DeepRL, including basically solving Rubik's Cube. So this is remarkable. And of course, there's been this fantastic result using first, with AlphaGo and then AlphaZero, showing that basically methods that don't have heuristics, that are fundamentally based on deep reinforcement learning and AI, can actually crack combinatorially large problems such as Go, which was thought to be unsolvable. So just very briefly for the audience which is maybe not familiar with deep reinforcement learning, deep reinforcement learning is really the concept of trial and error. I am an agent. Here I'm basically DeepPCB trying to solve and route a board, a PCB board. I have multiple actions. And then when I do actions, which is in the specific case trying to do routing different connections between pins, the environment is going to tell me, okay, now the system has changed. Maybe in the past you could pass through this way. Now you can't anymore because there are 2 layers that are blocking your path there. So you get back reward and observation. And reward in this particular case is really a function of how good of a solution you get. So it sounds like a simple principle, but if you iterate it at scale, this is where magic happens. And people have been skeptical of deep reinforcement learning early on, but I believe we are now at a time where this technology is considered really as a mainstay of modern AI, and we're seeing bigger and better applications of it all the time. And we believe this is important because what's the difference between this versus classical optimization solvers that are used in electronic design, for example? The difference is that, if you are using heuristics, it's going to be fast, but it's going to be ultimately limited. And the main limitation is the absence of learning. So you can see the situation as the following. You have complex electronic boards and chips to route and potentially also place in the future. And the question is, you're going to deploy massive compute, try to find a good solution. And there are lots of different algorithms that have been applied in this area for a long time, like simulated annealing and others. But the question is, if you do that, you burn a massive compute budget. and maybe next time around you're going to do the same and you would have learned nothing. So it's like you've used that compute budget just to get to a particular result, but you've learned nothing new. And at InstaDeep, we fundamentally believe that, you know, the world is changing because now you have methods that literally learn every time they perform an action. So in a sense, it's a bit like humans, like human experts. If you are, you know, like a trainee, you're going to learn a lot in early days, and then through the years, you're going to become an expert, etc. So it's like every time you've done it, like whether it's like routing boards or any other, like playing chess or playing Go, every time you play, you get better. Your intuition gets stronger. You have a more natural sense or intuition about where you should go. And this is what we believe is super exciting about deep reinforcement learning. It's the ability for the system effectively to build its own intuition, what we call intuition, which is basically digesting past experience and making sure you reuse it in the future in a good way. And so those systems, particularly with exponential progress in compute, have like significant potential. And at InstaDeep, we've been at the forefront not only of the research about these systems, but also their applications. So I'm mentioning here some of the results we got. We started as a startup with literally like 2 laptops and $2,000, but we were passionate about AI. And through time, we started innovating. We got our first papers accepted at the NeurIPS Deep Reinforcement Learning Workshop in 2018. And this year, we're very honored to have been accepted in their first joint collaboration with Google DeepMind. Google DeepMind today is considered as one of the leading, AI companies in the world, together with Google AI. And the simple fact that InstaDeep can collaborate with DeepMind and importantly get good results. Not only did we get accepted at NeurIPS, which is the largest AI conference, but we got accepted with distinction with a top 2% ranking globally and a spotlight presentation. So we have this ability to innovate. And actually we had the opportunity also to meet with David Silver and several scientists from DeepMind during the Indaba. And we were very surprised that the inventor of AlphaGo and AlphaZero actually mentioned publicly our work as innovative. And this is really like what we're excited about at InstaDeep. How can we bring innovative research into applications? And what you see today, DeepPCB, that we are basically presenting to the world for the first time, is the result of this effort of combining innovative AI research with practical applications and domain expertise. And it wouldn't have been possible without the domain expertise. Again, we're super excited to have fantastic people like Nabil and his team. And in total, we have 30 plus years of experience in the team of people who've been working in electronic design in electronics companies such as ST Microelectronics, Sagem, and others. So it is the combination of domain expertise in this particular field with innovative AI innovation around deep reinforcement learning that makes it possible for a small startup like InstaDeep to innovate and literally build something that has not been done to our knowledge. We believe this is a world first. And, and we believe this is very interesting because it opens up many opportunities. And in particular, there is a lot of technology, tech innovation under the hood. So I'm very proud also that the team has basically now 4 patents pending. Yeah, patents there. So we're excited about that. And importantly, this would not have been possible without our partners. We are, blessed to have amazing partners in tech. Of course, Google DeepMind is one of them. I mentioned the groundbreaking work we do with DeepMind and, in general, great collaboration with the Google AI and Google developer ecosystem teams. So our infrastructure and product is based on TensorFlow. It is cloud native. So from day one, all our infrastructure is actually leveraging, in this particular case, Google Cloud. And we believe there is a lot of exciting developments we're going to do around cloud. And importantly, it leverages also the expertise and the great scientific and technical collaboration we have at InstaDeep. InstaDeep has today 4 Google machine learning developer experts. I was the first, but I'm not the first anymore. We have 3 young talents in Africa, actually, who are today Google machine learning, like Google ML developer experts. And that expertise we re-inject into the products we do, such as DeepPCB. So this is important because DeepPCB is a cloud-native product. It can run literally on the cloud. If it can have as many, and can scale pretty much linearly with as many demands as you want to cover, and this makes a huge difference. And we also worked a lot with our partners in hardware. So I want to mention NVIDIA, who's been a great partner to us and who recently nominated us and elevated InstaDeep to the highest ranking in terms of collaboration. We are now a preferred partner with NVIDIA. This means that we collaborate actively. We're also users of basically NVIDIA GPUs, and in particular NVIDIA supercomputers. So we have DGX supercomputers in-house at InstaDeep, and we can bring that expertise and efficiency that we have through our collaboration to NVIDIA to our products and customers. So when it comes to GPU computing, which is another critical aspect of the work we do in DeepPCB, we're really very happy of the sustained collaboration we have with NVIDIA. But finally, we also are, in this particular case, and in DeepRL, strong users of CPU. This might sound a bit more unintuitive because people tend to think that, hey, AI, it's all about GPUs or cloud CPUs and the like. But actually, you need a lot of CPU to generate experiences. Again, deep reinforcement learning is all about how do I generate experiences, have agents who play the game, and ultimately reincorporate those insights into better models. And I'm very proud that we have a great collaboration with Intel through the AI Builders program. So InstaDeep is also part of the AI Builder programs. And that tight integration translates, for example, into new results we've published at the latest O'Reilly conference with Intel, where we showcased that we could improve basically performance on Intel Xeons and the like. But if you want to innovate in deep tech, I believe as a startup, you need to come up with your own disruptive technology and innovation. But you also need to collaborate with the leading tech players in the ecosystem, as we said, Google, NVIDIA, and Intel. And today we have that, and this allows us to innovate faster and bring those disruptive products to our users. So today we're at the beta release. What that means is that we're opening this to the public, and we would be very happy to have some feedback on that. So literally DeepPCB is going live as a routing engine now in Q4 2019. But importantly, next quarter we will expand the range of what we do. Today, this is a first, I would say, limited version where we would like to engage with, the hobbyists, the PCB hobbyist community, get their feedback about the type of features they want, and ultimately scale to larger boards. Today, we're limited to 150 connections. In the future, it will be in the thousands, and we are scaling up our systems. And ultimately, this point was mentioned by Nabil earlier, routing is just one side of the problem. We believe the future is having AI systems that can learn by themselves how to solve place and route. Like, how do you place the components? You can see this as another sequential set of actions that you are doing before you go to routing. But fundamentally, the scalable, no heuristics from first principles type technology that we are developing with our partners will allow groundbreaking results in that. So stay tuned for that. So that's for next year. But I believe it's important to provide some visibility and clarity about where we are heading with this innovative product. And we're very excited about it. Another reason why we're very excited about it is that we decided to open this to the community. So DeepPCB is free in its current version with up to 250 pins, 150 rat's nest, and 2 layers. And the goal is to engage with the community, learn together, build up the tools that people need to be able to ship their product to market, and importantly, ship it faster and at smaller costs. So it's an exciting time for us. Feel free to log into the platform. It's a first come, first serve because we had to put limits on capacity, but we will be very keen on interacting with PCB users answering their requests, hearing from them. We have a lot to learn. We're very humble that this is the beginning of the road. It's an exciting road, but still there is a lot to do. So this is a starting point, and would like to engage with the community and hopefully get some feedback. But there is potential, and it's an exciting time. So if I were to summarize where we are today, PCBs, we've seen PCBs are solved manually, which is time consuming. The reason why they're solved manually, it's not for the lack of autorouters, it's the fact that autorouters are not good enough. And the reason why they're not good enough is that they use limited sets of heuristics, and as a consequence, and we've seen a practical example, they may not necessarily connect all in the components, making it pretty much like limited in terms of utility. So people end up doing it themselves, as you've seen this user who said, I do it myself or with some software plus my insights, and then I check the autorouter and it cannot connect more than 80% of the pairs. So autorouters are very limited, and we believe the future are disruptive products like DeepPCB, which are designed from first principles, keep learning. These are systems that learn all the time, and importantly are fully scalable. They are end-to-end. There is no human in the loop, so the system can learn by itself at scale, and the more it will have experiences, the better will be the results. So we're very excited about this. DeepPCB starts in beta version today and is free. And so we're really looking at this exciting next step for InstaDeep. I have to mention that this is a first for us. First, it's the first time we do a live stream. So for those who are listening, if the live stream is working, thanks a lot for being here. But we believe that it's an interesting step because ability to deploy powerful technology such as deep reinforcement learning, not only for games, but for real industrial applications that are important, on which people spend tremendous amount of time to ship their product to market. We believe this is very exciting, and we're looking forward to the journey. Finally, I wanted to thank our tech partners who helped us and supported us along this way. If you had told me 3-4 years ago, what InstaDeep would be capable of as a startup founded in Africa, that one day we would be able to build disruptive products that have never been shipped to market before, and we believe again this is a first, even though it's a limited version, it is a first. Well, we're very humbled by the extraordinary amount of progress and excitement that we've seen internally, and the great work that the team has been doing. And it's also thanks to our partners. We've received a lot of support, a lot of positive feedback, lots of opportunities. Had we thought in the past that we could collaborate with DeepMind, be a partner with NVIDIA and Intel? No. Yet it happened, and it shows you that in today's world, if you are passionate about what you do, magic truly can happen. So we want to thank everybody who's been helpful on this way. And finally, last point, we are hiring. So if you are interested by reinventing the world of electronics design, please contact us. You have all the details. Thanks a lot for listening to us, and I think we can take some questions. Thank you. So we have a microphone, and I believe also on the live stream we can post questions on YouTube as well. Yes. Any questions? Don't be shy. Yes, go ahead. So we have a mic.
So I might have been missing something. First of all, thank you for a great presentation.
Thank you.
And within AI, so when you place this, or when you do the routing, how do you learn from it to the next time you place the routing, or the learning mechanism? Where does that come in, and the self-learning mechanism?
Okay, so yeah, perfect. So it comes from you are going to do something. So how does it start? The system starts completely random. The first thing it's going to do is probably not a good solution. But basically, you can rank if the solution is good or not, because depending on how many pairs connected, the length of circuitry, other variables that are important for how people route PCBs, you'll be able to say, this is a good solution or this is not a good solution. So in a sense, this is the needle in a haystack problem. if I show you the needle and say, this is a needle, you say, yes, I found the needle. But the problem is, where is the needle? And these are combinatorially explosive sets of solutions. So on a problem like DeepPCB, on a large board, you have way more solutions than what you would get in the game of Go, for example, which was famously solved by DeepMind 2 years ago. So there is a huge space, and the question is not necessarily like how do I rank a good solution or not. We can come up with reasonably decent ways to rank. The problem is how you find them. And this comes to really like technicalities of deep reinforcement learning, but I'll give you just the general intuition. The general intuition is like, I'm going to do lots of stuff. It might not be great, but some solution will be maybe better than others. And so if I tweak my system, remember, this is a neural network ultimately that governs this. Neural network has tons of parameters. If I tweak my system slightly through backpropagation to say, hey, this was a good solution, can you increase a little bit the probability that this could happen again? That's the way you learn. And actually at InstaDeep we've been innovative in that field. Our R2 algorithm that we published last year got us significant feedback from the AI research community, including David Silver. It led also to engagements. We now work with very large companies such as Deutsche Bahn on complex, in this case, routing trains. But the idea is, in the end, you're trying several things. You find something which is slightly better than what you're doing somewhere else. And if you're doing slightly worse, you reduce the probability and you iterate. That is your general principle. Again, in AI, I would say in most cases, the general principles are easy to understand, but to execute those is extremely hard. To make any type of progress in a deep RL type system is considered today very difficult. You need experts in multiple domains, applied mathematicians, engineer, and coding experts, but also experts of developing systems, like deploying systems at scales, literally hundreds, if not thousands of machines that work together to get to a solution. And today we've reached that critical mass at InstaDeep, and this is why we're excited about it, because we can innovate fundamentally and scientifically with patents deposited, but also deploy that innovation to customers, which I believe is the second part of the equation that most people sometimes forget. Like, it's all about getting your hands dirty and getting it to work, and this is why we're excited about this milestone today. So
another question: do you have an advantage of this yourself? Do you using those boards in your own calculations?
Well, we'd love to, but we haven't reached that size yet, yes. But you're right, there is a feedback loop there, that if you are developing more efficient boards, ultimately you can deploy more machine learning compute and iterate from there. I would say today, who could be doing that? Maybe Google could be doing that, but it's still in its infancy. Like, it takes years to develop an advanced chip when it comes to the ones such as the one Google has, which is a Google Cloud TPU one. So it takes years. But what is certain, though, is that using modern machine learning to improve the design of chips could significantly shorten the delay to innovate and ship in the next product or the next version of that supercomputer. So you could see, just to give you an idea, something that today is maybe taking 3-4 years. I personally would not be surprised in the next 5 years, the delay to market and from design to market and production, use in production is probably like 2 years. Like, could you reduce that amount of time by 50%? I believe you could, and that is significant. And it's the same for, PCB developers, some of them, many small companies with whom we're interacting. We've actually spoken to some of them. We believe that we could significantly shorten their time to market. If you think, for example, that in many cases you're pushing a product every year to market, this is new version, like this new version of iPhone, and there's new version of many things every year. If you could shorten that development cycle by 2 to 3 months, that's massive. That's 25% of time that you have saved. So we're looking at significant industrial efficiencies there as we develop and scale those innovative systems. Yes, we have one question. Yeah.
This is on. Yes. Okay. So I'm an InstaDeep employee, just for full disclosure. But I wanted to maybe ask a bit and maybe prompt a bit about when you talk about RL, a lot of the successes so far were in the space where there were existing environments. So an Atari game or an Unreal Engine or the Go board, which is kind of very simple to implement. But in this case, you needed to have access to a simulator that's industry compliant. And so in a way, it was kind of writing your own computer game from scratch. And could you tell a bit more about how much of that was in-house and how much of that was external software in terms of the simulator and the board modeling? Yeah.
Yeah, thank you. And by the way, that's Marek, who's ex-Google DeepMind. We're very happy to have him in our team. So basically, the interesting point here is that we've essentially built everything ourselves. And I'm actually really impressed by the performance of our team working across multiple locations in London, in Tunisia, in North Africa, and in Paris, in France. Being able to deliver on a complex, as you said, industrial product like this in that kind of amount of time is truly remarkable. Our point of view on this is we believe that small teams can actually be competitive in this time and age with large companies if they truly collaborate and act together. As I said, AI requires larger teams. I personally don't believe that AI progress can be really driven when you're talking about industrial products by a couple of people, but a tightly knit team of 10 to 15 extremely motivated employees can really deliver wonders. And when you mix the domain expertise we have, thanks to Nabil, our lead hardware engineer and his team, with the advanced deep reinforcement learning innovation that we have through our existing team as well, like it's truly remarkable. And actually I want to really say I'm really blown away by how motivated, passionate the team has been. I believe they're at their 4th weekend without taking any rest, so that we could deliver this presentation to you. So really, like, well done, guys. And this shows you the potential, and hopefully we take it from there and continue to improve. You know, so well done, guys. Yeah. I don't know if we have any questions online. Yes?
We have a few.
Okay.
So we'll start with further down the line, how would you qualify your unique selling proposition? As a routing specialist in a few hours versus a few weeks, or just better than the best routing specialist? Or maybe both?
Yeah, I think, you know, in general, like what InstaDeep, what we've discovered, because we didn't have this ambition to start with, what we've discovered is that we could be innovative and go beyond, in certain cases, the state of the art when it comes to industrial applications of deep reinforcement learning. We are a bootstrap, so we've learned from day one to listen to customers and solve their problems. Otherwise, we wouldn't be here. But at the same time, with the innovation capability we have, we can now really have a go at complex problems. And yes, those are around decision making. You know, they involve routing in many cases, so we're active in logistics. We're now very active in electronic design. So there is a commonality around those. And so, yes, the goal would be to deliver a great solution, potentially as good, if not better, of what exists already, but importantly, save time. Like we've spoken to users, actually Nabil and the team sat down with multiple actually designers of PCB boards, people who ship their own hardware in the US, they built it in China, they ship it in the US and Europe. And the feedback was, the key element is the cycle time. If we can reduce cycle time, that is a massive home run for those developers. And of course, the solution needs to be at a level of quality which is acceptable. Ideally, it's even better than what others do. But if you can reduce cycle time with an acceptable solution from weeks or months into 24 hours, this is incredible. This is truly disruptive AI at its best. And today at InstaDeep, we believe it's possible. This is the first step we're doing with DeepPCB. So if you try DeepPCB, you'll be able to get results in 24 hours, no matter what you send, provided it's within the limits that we set. But in the future, we're going to expand to more and more complex boards. So yes, we believe that we can significantly help on that front.
Thank you. We also have one more specifically on the tool. If you can reiterate the tools that have been used to build the solution.
So really, like, we've built it from scratch. It sounds incredible to say, but actually we haven't used any particular tool. One of the reasons is we actually have experts of high-performance computing in the team, and also there were certain ways in which we had to design basically the routing system such that it would be fully compatible with deep reinforcement learning and advanced AI. And I believe that's the future. I'm not necessarily convinced that legacy tools, which haven't been designed with AI in mind and end-to-end cloud scalability, are necessarily the way forward, and they will probably need to be reinvented by people who really have a good sense of what is required from both a scientific point of view, but also like an engineering and high-performance computing point of view. And this is actually critical for success. Let's put it in this way. Like if you have a great tool, but it's super slow, there is no way you're going to be able to deploy deep reinforcement learning, because these methods are extremely heavy in terms of number of experiences you need to accumulate to get to results. If you do not understand the specifics of the problem and how to crack it in ways that make it amenable to deep RL type technologies, that's going to be a problem. So I believe actually this is one of the reasons why we're among the very few who can deliver this kind of products end-to-end, is you really need to mix those competences. But to answer strictly your question, no, we did not use any existing tool, so this is genuinely new and innovative.
And just to touch a little bit further on what you kind of already said, if DeepPCB is a fully RL-based tool, or does it include also heuristic methods to optimize routing?
And this is what we are really excited about. This is the first pure AI deep RL powered system in the market, and so this is to our knowledge, and please correct us if we're wrong, it's a world first, and we're very excited about it. So there is literally no heuristic which is built in the system to sort of like tweak certain sets of solutions versus others. The system tries to be as rational it can be. An example of that line of thinking is like what Garry Kasparov said about chess when AlphaZero came up and basically beat Stockfish and all existing software systems and it's in a couple of hours, like in 4 hours, AlphaZero learned to beat Stockfish, which was at the time the best software system for chess. Garry Kasparov said, I'm really excited about AlphaZero because in certain way it represents the truth. So it has no bias, and so as a consequence, the style of play is sort of the right way. But also he said that because AlphaZero is very aggressive, like Kasparov used to play, so he wanted to say that. But this is kind of the line of thinking. We try to avoid heuristics, and I think that's the reason why those systems eventually will be way more powerful than any existing autorouter in the market today. I mean, we know autorouters are bad today. It's not us saying that, it's literally users. And so we believe, it's a significant milestone that DeepPCB is now competitive with autorouters, but we believe we can go way more and way further than that. And that the future is about learnable system where you try to minimize bias. So it's really like in the sort of like the Richard Sutton way of thinking, which is design a learning algorithm and let reality and truth reveal itself progressively. Those systems will significantly enhance the state of the art.
Amazing. I think we only have one more before we have to cut it.
Yep.
I just want to finish with, would you publish any benchmark versus industry-proven routing and placement tools?
Yes, good question. Definitely we'll work on benchmarks. To be very clear and very humble, this is just a first start. This is our beta. So we're not claiming that we've solved all the problems. We're claiming that this is an interesting angle that we believe has not been explored, or at least in a publicly available product before. And so we are actually very interested in the feedback of the PCB and hobbyist community. And actually, I appreciate those questions, which are very relevant. So we'd like to hear more from you guys. But yes, in the first half of next year, we will definitely publish benchmarks. And also, I encourage everybody who's interested to come and use the tool. You have available capacity, which is there for free. use it. Give us your feedback once you've used it. Is it good? Is it bad? It certainly can be done better, and it will, hopefully. But we are also learning, and we're very humble. We have never done this before, but we're very excited about it. So hopefully by collaborating with the open source and PCB community, we can accelerate the development clock. But yes, next year we will definitely publish benchmarks, and I believe those will be very promising. Cool. Again, thanks a lot for your time today, and for everybody who's been following us online. It's a first for us, so your feedback is welcome, and I hope there hasn't been too many technical glitches, or no Cybertruck glitch, or at least not a big one. So thanks a lot for your time today, and looking forward to interacting with all of you in the future, and have a nice day. Thanks.